This section deals with two specific cases where trigonometry is utilized to solve an area calculation. And the good news is that I already covered the first one in section 10.3. Section 10.3 dealt with finding the areas of regular polygons. In that section, I ended the discussion laying out how there are four cases that came up when dealing with them. Equilateral triangles, squares, and hexagons all ended up with special triangles formed by a radius and an apothem. All of them could result in exact answers. Section 10.3 dealt with these three cases. The fourth case encompassed all of the rest of the regular polygons, pentagons, octagons, and the rest. I told you, and showed you, during section 10.3 that all of these polygons ended up with triangles where you're going to need to use SOHCAHTOA in order to solve them. This section's practice problems deal with this case. Expect to do many problems where you use SOHCAHTOA to help you find the areas of regular polygons that aren't triangles, squares, or hexagons. We have dealt with SAS a lot this year as it pertains to triangles. We used it to prove triangles congruent. We used it to prove triangles similar. We can use the law of cosines on a triangle with an SAS pattern. And then in this section we can use a special formula to find the area of a triangle with an SAS pattern. So many different ways SAS has come up this year. Here is the formula for this section. It has a similar pattern to the right part of the law of cosines formula. You don't need to know all three versions of the formula. They all refer to the same pattern. You must start with an SAS pattern on your triangle to use it. Here's a quick example to show it in action. I am supposed to find the approximate area of this triangle. Handily, it has an SAS pattern, so I can use the formula from the previous slide. Plugging in the numbers, you get this. Then it is just a matter of crunching numbers. The question said to round to the nearest square inch, so my final answer would be this. That's really all there is to this section.